All right, first one here, we have a binomial to the third power. So remember, we're not allowed to send in that third power because of the addition. So I would want to write this 3 times, and then we're going to multiply it all together. So we'll go x plus 5y, x plus 5y, and then x plus 5y. So we'll FOIL 2 of them together. So this will be x squared, and then 5xy and 5xy will make 10xy, and then 25y squared. And so now we're going to need to multiply that by x plus y again, which is where I usually use the box here. So we get x to the third, we get 10x squared y. Oh, this is 5y. Okay, we'll fix that right there, no problem. And then this will be 25xy squared. And then we have 5x squared y. And then we have 50xy squared. And then 125y to the third. So we can just combine the like terms here that are kind of working diagonally, and then that'll be your final answer. All right, next up here, we're doing some factoring, and it looks like we have 4 terms, so we'll try out the grouping here. So it looks like the first group, I could take out 7x squared, which will leave me with x plus 3. And the second group, I think I could, let's see, I could take out a negative 9. Oh, actually, I can take out 63, which will be negative 63, which will leave me with x plus 3 as well. 63 times 3 will be 189. All right, and so that gives me 7x squared minus 63 times x plus 3. However, I see that actually here, these can both divide by 7, so I'm going to take that out front and call that x squared minus 9. That actually kind of means that I could, these all in the original question could have been divisible by 7. So if you took the 7 out at the beginning, then that's also fine. I probably should have done that, but it's also okay if I take it out at the end now. But now I see that I can factor this some more as x minus 3, x plus 3, and x plus 3. But since I have x plus 3 twice here now, I can write that as x plus 3 squared, since those two are multiplying by each other. All right, next up here, these are perfect cubes. So we're going to do our one small parenthesis and one big parenthesis. The small parenthesis for me will be 5x. And then this one will be y squared, because that's kind of the cube root of y to the 6th. And so I'll let you guys fill out the rest of it there. All right, here we're going to use our use substitution. So we got kind of a lot going on here. So I'm going to let u equal the weird thing in the parentheses here that shows up. And I'll use another variable. I'll go ahead and use y for 5x minus 6. All right, and so as I'm doing this, I'm going to multiply all like the regular numbers together. So this is going to give me 18 u to the 1/3 and then y. And over here, I'm going to multiply the 1/3 and the 3 together, which actually equals 1. So I'm not even going to write it. And so that'll give me plus 1 u. Oh, actually, that's y. So y squared and then u to the negative 2/3. All right, so we're going to GCF here. So it looks like what I can take out is u to the negative 2/3 is the smaller exponent for the u's, and just 1y there is a smaller exponent for the y's. And so this one will become 18. And then for this one, I'm going to calculate it as 1/3 what I had minus what I took out. And so that's going to be actually 3 over 3, since that'll turn into addition. And so that'll give me 1 u there. I don't have a y. And then over here, I'm going to have 1 y left, but my u to the negative 2/3 has been taken out front. I'm going to go ahead now and we'll plug everything back in. So this will be 4x plus 3 to the to the negative 2/3. And then y is, 5x minus 6, okay. And then this 18, I'm going to have to distribute into 4x plus 3. And then I'll have to add my 5x minus 6, no distributing for that one. So go ahead and distribute that. Let's see, what is that? 9 times 8 really is 72x. And 18 times 3, 9 times 6, 54, plus 5x minus 6. And then we'll combine like terms in there. So that would be 77x plus 48. And then we'll go times 5x minus 6. And then let me get some more space here. And then with the negative 2/3 power, they're probably going to want you to drop that down to the bottom and then call that now the positive 2/3 power since we moved it. All right, so similar idea here on number 5. So I will let you guys try that one out. Oh, you know what? I better do this one because there's a kind of aspect at the end. Okay, so let's do this. So let's do u equals 3x plus 1. And then let's do y equals 2x minus 5. And so as we write this then, I'm going to multiply the numbers again. So 1/2 and 2 are going to multiply to 1, so it's kind of gone. So I have u to the 6th and y to the negative 1/2. And then over here, I'm going to have 24 for me, multiplying those guys. And then I'll have u to the 5th and y to the 1/2. I kind of changed the order on that. The order doesn't really matter. That's just what I saw first. All right, so we're GCF here. I can do u to the 5th, and I can also do y to the negative 1/2. And so that'll leave me with u times y here. Oh, no, it won't be y. It'll just be u there since I took out the negative 1/2 power, and then it'll be plus 24. That one, the u is gone, and my y is going to increase to 2/2, which will just be 1. So now I'll plug everything back in. So I got 3x plus 1 to the 5th. I got 2x minus 5 to the negative 1/2. And then I have 3x plus 1 plus 24. And then I'll go with a bracket here with the 2x minus 5. All right, and so we'll go ahead and distribute and combine like terms over here. So we'll go plus 48x minus 120. Combine like terms in there, and we get 51x minus 119. And then the last thing we need to kind of double check here is does this one have a GCF, which actually this one does. It's 17. So we got 17 times 3x minus 7. So that's going to be my kind of final from over here. So I'll use that, and I'll kind of write my final answer. I'm going to go ahead and put the 17 out front, and then we have our 3x plus 1 to the 5th. I'm going to move the 2x minus 5 to the 1/2 on bottom, and then I'll put my 3x minus 7. So that would be my final answer. All right, next up here, we got a binomial times a trinomial. So I always use the box for that, so I'll let you guys do that. All right, same idea here. We're going to have another box. So I'll draw that one here. I'll do this one. So we get minus 2y to the 1/3. Okay, just the one thing I wanted to point out is that when we are multiplying these together, and so kind of I'm multiplying this one times that one, remember that means adding the exponents. So this will actually be the first power here because it's 3/3. This next one will be 2x to the 2/3 and then y to the 1/3. Wish I would have made that box bigger. And then this one will be 4x to the 1/3, y to the 2/3. I'm not going to add the exponents if it's different variables. So then this one will be negative 2x to the 2/3, y to the 1/3. And then this one will be negative 4x to the 1/3, and then I'm going to add the y exponents, so that'll be y to the 2/3. And then the last one over here will be negative 8, and then that'll be y to the first power because I'll add those and get 1. So you'll notice actually we get canceling out here, and so it should just leave me with 8 minus xy. All right, next up here, factor, and so this one will be grouping here. So looks like I can take out x to the 3rd, which will leave me with x plus 5, and then a negative 1, which will leave me with x plus 5 as well. So it'll be x to the 3rd minus 1 times x plus 5. And then we can break this down further using our perfect cubes pattern. So make sure you get some practice at that. All right, next up here, we got some more factoring. So we're going to think of two numbers that multiply to negative 125 and add to positive 124. So I think that's pretty clear. It'll be positive 125 and negative 1. So I'm going to go ahead and do my grouping here, but when I do this here, it's going to be 125y to the third minus 1y to the third, because we're splitting up that middle term, which is the third power. And this becomes very important because now when we group, we can take out y to the third power, which would leave me with y to the third plus 125. And here we can take out negative 1, which would leave me with y to the third plus 125. All right, so then this can become y to the third minus 1, and then y to the third plus 125. So then actually both of these should be split up some more, since we're going to have SOAP on both of them, so I'll let you practice that. All right, next up here, we're going to go ahead and solve this equation. So it's already kind of isolated for us here, so cosine theta equals -1. So the only place where cosine theta equals -1 is really over here at -1, 0. So we know that that radian value is pi, but it wants us to put it as a formula where k equals any integer. And so since it's only one answer there, I'm just going to say pi plus 2 pi k. There's no diameter buddy to go with it to let me do the pi k. All right, next up here, we're solving a trig equation again, so I'm just going to get one side to 0. So we got sine squared minus 3 sine minus 4 equals 0. So I'm going to move everything to the left. You can use substitution if you want. I'll go ahead and use that. So we're going to think of two numbers that multiply to -4 and add to -3. So that would be -4 and 1. So it'll be u minus 4 and u plus 1. And so I'm going to plug this back in. So sine of theta minus 4 times sine of theta plus 1 equals 0. And so that means here that I can split these up and solve them individually. So if this one equals 0, then sine of theta will equal 4. And if this one equals 0, then sine of theta equal -1. Now, sine of theta equaling 4 is actually never happens. It's too big. Sine and cosine can only be between -1 and 1. But sine of theta equaling -1 is possible down here. And so that is 3 pi over 2. But it asks for all the solutions. So that's only one solution from 0 to 2 pi. And so I'm going to say theta equals that 3 pi over 2 plus 2 pi k. All right, next up here, we got some fractional exponents on numbers. So for numbers, it's kind of the only time I would switch it to the root here. So it's the 4th root of 81. And so you're just going to think of the number that if I multiply it by itself 4 times is going to give me 81, and so that would be 3. So 3 times 3 times 3 times 3 will give you 81, so that means that's the 4th root. All right, next up here, part B, we have -64 to the 1/3 power. Now, this negative is kind of multiplying out front, so I'm just going to think of that like this, like that negative is going to be the last thing that I do. And so I'm going to do the cube root of 64. So the number multiplied by itself 3 times gives me 64, so that's 4. But now I'm going to take care of that negative, so I'm going to have that negative outside, so it's actually -4. Now, part C is a little bit different here because we have a negative exponent. So negative exponents, that moves it down to the bottom, so it'll be 1 over 9 to the 1/2. So you see there the difference between a negative number and a negative exponent. And so that would be 1 over it's actually the square root of 9, so that'll be 1 over 3. That one is not negative because a negative exponent does not create a negative number, it just moves it down to the bottom. All right, next up, number 13, I'll go ahead and do B, and you guys can do A. So first on B, I would take care of the parentheses here, and so I'm going to remind myself that that's 1, and I'm going to send that in there. So I'm going to keep this a to the 5 over 4 the same, and this will be 3 to the 3rd, and then a to the 9 over 4. Remember, that's 3 over 1, so we'll multiply top times top up top, and bottom times bottom on bottom. And so on bottom here, I have a to the 1/4. All right, so now I'm going to combine, or actually on top, I'm going to turn the 3 to the 3rd into 27. I'll combine my A forces there, so it looks like we have 14 over 4 now. I'm actually not going to reduce that because I see I have to battle this out, and so I'm just going to keep it as a common denominator. And so obviously the top's going to win that battle, and so I'm going to have 13 over 4 in my exponent. All right, next up here, we are going to go ahead and do the kind of similar thing here. I'll go ahead and do B, and so we'll multiply this in. So this is 4 to the 1/2. 16 times 1/2 is 8. And then 1/2 times -1/2 is -1 over 4. So that is multiplication there, and then this is also multiplication. So this will be 32 to the negative 1 over 5. And then s to the power of, and let's see, 5 over 4 times 1 over 5. That's actually going to be 1 over 4. And it'll be positive since we were multiplying there, a negative times a negative. Okay, so a couple different ways you can go from here. You could start adding exponents now. I actually prefer to get rid of the negative exponents by moving them to the bottom. So that's how I do it. So I'm going to go 32 to the 1/5 down here. I'll keep my 4 to the 1/2 up here. We have r to the 8th up here. S to the 1/4 will go to the bottom. And s to the 1/4 will stay up top. All right, so now we can go ahead and battle it out here. But you know what? The numbers here, so I know this is the square root of 2. And I know that this is the 5th root of 32. Oh, sorry, this is the square root of 4, and that's the 5th root of 32. So that is actually going to be 2 over 2 here, because the 5th root of 32 is also 2. My r to the 8th will stay up top. And then these s's will actually cancel out, and the 2's will also cancel out, so I would just be left with r to the 8th there. All right, here we're going to factor. I would use a u substitution, so I'm going to let u equal a plus b, and we'll do 5u squared plus 19u minus 4. So do a diamond here, so we got negative 20 on top and 19 on bottom, so that'll be 20 and negative 1. But since I got that 5 out front, I got to split this up as 20u and negative 1u, and then rewrite the other terms. So now we'll do the grouping. The first group, I can take out 5u, leaving me with u plus 4. The second group, I got to take out a negative 1, which leaves me with u plus 4 as well. And so now I have 5u minus 1 times u plus 4. I do have to plug this back in, but I got to be careful here when I'm multiplying that one. The 5 has to distribute into the a plus b. So I always use brackets to kind of show that. So I don't get them confused with the parentheses. So then my final answer here would be 5a plus 5b minus 1 times a plus b plus 4. All right, next up here, we're going to do some more factoring. So it says begin by factoring out the lowest power of each common factor. So we're going to take out the smallest exponent here, which is the negative 1/2 power. And then, so that'll leave this first term is 12. And then plus 7, and this one will have a power. And so what I always think of for the exponents is what I had minus what I took out. And so I had a 1/2 in this term right here, and I'm going to take out a negative 1/2. And so 1/2 minus a negative 1/2, that's actually addition. So it's going to turn into 2 over 2, which is 1. And then I'll do it again here with the 3 over 2 minus what I took out. And so that's 4 over 2, so that's x squared. I think I'm going to be able to refactor this inside, but I'm going to go ahead and rearrange it like this. And so that's just a diamond here, multiplying to 12 and adding to 7, so that sounds like 3 and 4. No a values, so this is pretty easy factoring here. You can just use the shortcut x plus 3, x plus 4, and don't forget about that x to the negative 1/2 there. They may want you to put that on the bottom as x to the 1/2, so that's fine, like so. All right, next up here, number 17. So I'm going to use u substitution here, so we'll call it u minus 7. So we have u to the 7 over 2 minus 49u to the 3 over 2. So I'm going to factor out u to the smallest power, which is 3 over 2. And that'll leave me with, and once again, I always want to subtract these exponents based on what I had minus what I took out. So I'll do 7 over 2 minus 3 over 2, so that's 4 over 2. And so that's 2, so it'll be u squared. And then minus 49, and then that one is kind of just gone because I took out that whole power. Okay, now I'm actually not done factoring here because I see inside I can do a difference of perfect squares, so I definitely want to do that. So that'll be u minus 7 times u plus 7. And now I'm going to plug this all back in and kind of see what happens here. So this will turn into x minus 7 to the 3 over 2. This will be x minus 7 minus 7, and this will be x minus 7 plus 7. I did not need to use any brackets here because nothing was kind of no negatives or multipliers in front of the u. There was a negative in front of the 7, but that's not what I'm plugging back in here. I'm just plugging back in u. Okay, so now I'm just going to combine like terms. This first piece looks like it's already in factored form, so that one's good to go. This one looks like it's going to turn into x minus 14. And then this one looks like it's actually going to turn into just, these will cancel out, and that'll just be x. Now, whenever I have the x, I like to put that out front. I think it's okay kind of no matter where you put it, but I like to put that out front. All right, next up here, number 18. So we'll use some more u substitution here. I'll make u equal x plus 3. And so we have x and negative 1/2. So you'll notice that I am going to turn the x plus 3's into u, but the just plain x's I'm going to leave as is. And so we'll go plus x to the 1/2 times u to the negative 1/2. And so now I'll do some GCF here. So for the x's, looks like actually for both of these, the smallest exponent is a negative 1/2. So I'm going to take that out of both terms. So on the first term, the x will be gone and the u will increase because I had 1/2 minus a negative 1/2. So that'll be 2 over 2. And then we'll go plus, and then let's see. Okay, so now this one, the u is going to be gone, but the x is going to increase. It's going to be the same thing here. It's minus a negative 1/2, so that's 2 over 2. So that'll be just x. Okay, so now I'm ready to plug back in. So we got x. Actually, I don't need a parentheses for that. So x to the negative 1/2. And then we have x plus 3 to the negative 1/2. And then we have x plus 3 plus x. Nothing to distribute into that u. So I would just combine like terms here and call this 2x plus 3. And then I would drop my negative exponents down to the bottom. And so I would call this x to the positive 1/2 now since I moved it. And then, what is it? X plus 3 to the positive 1/2 as well. All right, next up, number 19. So for this one, we want to use our u substitution, but these are different. So I'm going to use a second variable here. So I'll let u equal a plus b, and I'll just let like y or whatever you want equal a minus b. So this is going to be u squared minus y squared, which I can only factor with difference of perfect squares. So we got u plus y, and then u minus y. So now we'll plug back in, and the only thing I got to be careful of here is the negative y, so that's going to have to distribute. So I'm going to go a plus b plus a minus b for the first parentheses. The second one will be a plus b minus bracket a minus b. All right, so now I'll go ahead and distribute that negative, so it'll be negative a plus b here. And then we can cancel out a's, and then b plus b is 2b. Not b squared because these are not multiplying, we are adding them. All right, and then next up, over here we can combine like terms, which actually the b's cancel, so we get 2a. Next up here, I would multiply these together, and we're going to call this 4ab. It's I know that distributing, we don't want to do that if our goal is factoring, but that's not really distributing. This is just kind of multiplying, and so 4ab is the best answer for that. Remember that our goal for factoring is to write them as kind of things that are multiplying by each other, and so 4ab is definitely multiplying. All right, we get another u sub here, so we'll go u equals x squared minus 36. So then we can call this x squared u minus 25u, which means we can just GCF a u here and call it x squared minus 25. We'll plug back in as x squared minus 36 times x squared minus 25, and we'll just break those down as difference of perfect squares. I'll let you guys do that. All right, next up here, we've got the, we're going to find the common difference here. So that's just kind of the pattern, what's being added. So it looks like it's a plus 13 pattern. So I shouldn't put plus 13, I should just put 13. If it's decreasing, then it's going to be negative. Okay, so then a sub 5, well, if you just added 13 again, it would make sense that it would be 49. And then for a sub n, that's like the what do you call it, the formula for this. So I always think of that as a sub n equals dn plus a sub 0. I think of that just like mx plus b. So the slope, the m, is common difference, is what you're adding each time. And then a sub 0 is kind of hypothetically, what if there was another term in front of the first term? So you can see that that would be a bigger negative. And since my pattern is 13, I would have to make that negative 16. You can check your pattern here. So if I plug in 1, I should get the first term as negative 3, and you can see that I do, so that's good. If you plug in 2, 13 times 2, I should get my second term, which is 10, which I do. So that you can always kind of check that pattern there. So 13n minus 16. And that makes it really easy to find a sub 100 because I just do 13 times 100, which is obviously 1300, minus 16, which is 12. What would that be? 1284. All right, another arithmetic sequence here where they give me two terms. They tell me a sub 12 is 94 and a sub 8 is 130. So for these ones, we always want to find the common difference, which is really the slope. And so we're just going to do y2 minus y1 over x2 minus x1. It doesn't matter what order you do these in, as long as you kind of do the bottom in the same pattern you do the top. And so you can see 8 goes with 130, so I line them up like that, and then 12 goes with 94, so I line them up like that. These are our x values because that's really what we're plugging in, and then these are our y values because that's what we're getting out. All right, so I'll just simplify that. So obviously the bottom is -4. The top here is 6 and 30, so that makes 36. And so that's going to be -9 for me for my common difference. So what I can do then is I can set up my kind of equation here. So I can say a sub n equals, and then I'm going to use my a sub n equals dn plus a sub 0. So that would be -9n plus a sub 0. So I'm going to figure out what that is here. And so I'm going to kind of, since I know the common difference, I plug that in. Now I'll plug in just either one of these points. I'll go ahead and use the second one since that 8 is smaller and that's when I'll have to be multiplying. You could use either one though, get the same answer. So I'll multiply that in there. And then that gives me -72 plus a sub 0. And so then I'll add that 72 over. That'll give me 202 equals a sub 0. So now I can write my formula, which I know is actually the second part here, but that's okay. -9n plus 202. And then that makes it really easy to find a sub 1 because I'll just plug in a 1. That'll be -9 plus 202, which would be 193.